The next class we want to look at will be an extension of line, which I call fancy line. And we'll scroll down here to take a look at fancy line a bit. And fancy line extends class line, so it inherits all of the properties of line, which mean that unnamed point is a starting point and the end point, and these behaviors, the line constructor and the line toString method. So a fancy line conceptually is just a line that has a style to it. Maybe it's a solid line or a dashed line or a dotted line, and that's the meaning of fancy line. Now, fancy line extends class line, so already it's got a start point and an end point and some behaviors, but we're going to add to that a width so that the line can draw itself in wider or narrower form. So the width is meant to be pixel width on a drawing palette. And the second private instance data member is called draw type, and it's just a simple string, and here we'll store a word like solid or dotted or dashed to indicate the style information, and this will be fine for our text-based graphics example. Now when we look at the constructor of fancy line, it gets a little bit more data. It gets the same 4 points that line needed, and then a width, W here, the pixel width, and the string that describes whether it's solid, dotted, or dashed, or so on. So the first thing inside the constructor here on line 45 is a call to its superclass. That's the line constructor to construct the line subobject that's contained in every fancy line. Now, when we call the constructor here from line 45 on that first line subobject contained in every fancy line, we go up here and invoke the line constructor on line 26, which in turn invokes the point constructor from here on class point. So that cascading back up through the inheritance hierarchy is one of the signature features of inheritance behavior. So line 45 initializes the line subobject that's contained in every fancy line by inheritance. The next 2 lines initialize the other 2 instance variables. The width gets initialized to the parameter W that we pass in, and the draw type is just initialized to the string S that we pass in as the word that describes the style of the line. Then when we write the toString method to be able to draw out a fancy line as text on the console, we're once again going to piggyback on the behavior of its parent class. So we'll return the string that names the draw type, whether it's solid, dashed, dotted line, the method to our superclass here to implement toString will give us a print representation of the line, and then we concatenate onto the end of that our specific width. So this will comprise the total behavior of fancy line printing itself out to the console. So now to test out that code for fancy line, I've scrolled down here to the main method, and we'll create a fancy line named to, and we'll call the constructor with those 6 arguments, and then send to the console by simply doing a print line on it. So we'll go ahead and compile this to make sure we get a clean compile, and then go ahead and run this code and see if the output looks right. So we get our output from previously, which output the origin and line 1, and now fancy line 2 here is sending its output to the console, dashed line from 0.34 to 0.56 of width 1. So our test indeed does work. So looking back on our code now, we can use JGrasp to get a graphical vision and view on this inheritance hierarchy. In JGrasp, if you define a project for your code, you can do this from the project menu. You create a new standard project, and there's a dialog box here to complete. You simply direct it at the folder where your source code is contained, and you can add files from that folder to the project and create the project. I've already done so here. It creates another file called your project name.gpj for JGrasp project. I've already created the project, and once you do that, there's another button here you can invoke right here that generates a UML class diagram. UML is for Unified Modeling Language, and it's just a standard way of diagramming these classes. And generating the UML results in a UML diagram that looks like this for the class that we've written so far. Now, there's a couple more classes to go in our example, but here's our class point, which we started with, and then we had class line, which extended point, and the inheritance relationship is shown here by an arrow with the triangular head on that, and so line extends point, and then likewise fancy line extended line. So this three-level diagram here shows the inheritance relationships between these three classes. This also helps to decide where you put certain functionality or features. If each class only needs to know about its immediate parent class and only interacts with that immediate parent, you don't have to worry about going 2 levels or 3 levels or 4 levels deep in this inheritance hierarchy. For instance, fancy line does have the primitive XY data that we defined on class point, but it doesn't directly do anything with it. Fancy line does all its work through its parent class line, and line worries about the fact that it has XY point data to deal with for the start point. And so if each level in the inheritance hierarchy only worries about itself and its immediate parent, if you program in that fashion, then you can place the behaviors where they need to be, and your interface is quite simple. The interface is simply between you and your parent class when you need to use the inheritance mechanisms. So that's what's shown on the left side of the diagram. And then on the right side of the diagram, there's a couple more classes we need to describe yet, circle and cylinder. But here's our main class. It was called text shapes, and it contains our main method. And these arrows are references. Whenever we use composition, for instance, we will see these kinds of references. So our main method created a point and a line and a fancy line. That's why those red arrows are there. So composition in general is shown with these red dashed arrows, and inheritance is shown with these solid black hollow head arrow-ended arrows. Another interesting feature of these UML diagrams is that we can click on things and see the corresponding code. So for instance, if I double click here on fancy line, it takes me to the code for fancy line. Going back to the diagram as well, if I highlight a particular class, say point here, over on the left side there's this UML info tab. Selecting that shows me the properties of that highlighted class. So class point here, for instance, has fields, private instance variables X and Y. Fields are just another name for the instance variables that JGrasp uses. Its constructor is right here. It's a point constructor that is public and takes 2 integer arguments, and it's got a two-string method as well. If I click on line, we see that class line has a private instance variable endpoint. That's where the composition worked. It's of type point and it's private. And it has a 4-argument constructor taking 4 ints and its own 2-string method as well. And then lastly, fancy line, we look at the properties over here. That added a draw type and a width. Has its own constructor, and it takes 5 integers and a string as an argument, and it too implements its own 2-string method that piggybacks on its parent. So the 2-string method really illustrates the idea of inheritance at work with regard to behaviors. Fancy line has a 2-string method that in its body invokes its parent's 2-string method. Line, in turn, invokes its parent's 2-string method, so all 3 classes are involved in giving us that last line of output. We run it again just to see that, in effect, in this last line has output where some of the text came from each one of those classes in the inheritance hierarchy. So think about defining projects in JGrasp for your code. You ought to be able to look at the same code with either Eclipse or JGrasp from the same directory. That shouldn't matter. And look at the UML properties from a defined project. You can then go and generate the UML info from the code using this button right here. And then once you have the diagram generated as such, you can highlight certain elements and look on the UML info tab to see particular properties of just that isolated class.